we're going to start 7, which is about complex numbers, and we're going to start off learning about standard form for complex numbers. So our objectives, we're going to define imaginary numbers, define complex numbers, and then we're going to learn how to add, subtract, multiply, and divide complex numbers. And then we're going to solve equations that have complex numbers in them. And also we're going to solve equations when we solve them, our solution is going to be a complex number. So the first thing I want to review with you is, what is an imaginary unit? What's an imaginary unit? Okay, so an imaginary unit, which we call I, is when you get the square root of -1, okay? So, square root -1. And it just so happens that I squared is equal to -1. And remember, we learned that the reason that I squared is equal to -1 is because if I is equal to the square root of -1, that means that I squared is the square root of -1 squared. And when you have a square root and a square, those cancel, leaving you what's on the inside, which is -1. All right, so now that we've reviewed what an imaginary unit is, I'm going to explain to you what a pure imaginary number is. So pure imaginary number. And that's going to be a multiple of imaginary units. Okay? So multiple of an imaginary unit. So it's going to be in the form of AI, where A can be any number that's not 0, obviously, because there was 0, it wouldn't exist, right? So for an example, you could say 7i. That's a pure imaginary number. Okay? So now let's talk about, well, if that's a pure imaginary number, what's an imaginary number? Okay, an imaginary number is any number containing the imaginary unit. It can be a pure imaginary number or the sum of a real number and a pure imaginary number. So every pure imaginary number is an imaginary number, but not every imaginary number is pure, right? To be pure, you will just be the imaginary unit with the multiple on it, okay, or just the imaginary unit. Okay, to be an imaginary number, you're going to have an imaginary unit, but you could also be being added to another real number. So any number containing the imaginary unit. Okay, so for example, we have 7i. We could also have 7i plus 3, right? It could be something like that. Okay. So let's talk about solving equations and getting imaginary, and we get an imaginary number. So I'm going to do an example. So this will be example 1. And in example 1, we want to solve x squared plus x plus 1 equals 0. Okay? Well, I'm going to use the quadratic formula. So we have to remember what quadratic formula is. Okay, which is x is equal to -b plus or minus square root b squared minus 4ac all over 2a. Okay, so when I plug in my a, b, and c values, so a, B, and C, everything's 1. A is 1, B is 1, and C is 1. So that means I get x is equal to -1 plus or minus square root 1 squared minus 4 times 1 times 1 all over 2 times 1. Okay? So from there, it's x is equal to -1 plus or minus 1 minus 4 is -3. So 1 plus or minus the square root of -3 all over 2. Okay, so here is a negative. Here's a negative. All right? It's not quite an imaginary unit yet because remember, I is the square root of -1. We don't have the square root of -1. We have the square root of -3. Not the same thing. However, the square root of -3 can be broken up. It could be rewritten like this. X equals -1 plus or minus. The square root of -3 is the same as saying the square root of 3 times the square root of -1. Okay, so that helps. Now I've got a square root of -1. It's still all over 2. So now that square root of -1 is going to become an I, right? So we end up with x is equal to -1 plus or minus square root of 3i all over 2. So very last step is that I want to split the real part and the imaginary part up. So since this is -1 plus or minus the square root of 3i all over 2, I can break this up, and this is going to become x is equal to -1 over 2 plus or minus the square root of 3i over 2. All right, so that will be my solution right there. Then we're done. All right, so why do we break it up to the real part and the imaginary part? Well, that's because we want to apply the definition of complex numbers. So we're going to get that definition next. A complex number is the union of the sets of real numbers and imaginary numbers. Okay, standard form, which is what this whole section is about, is A plus BI. Okay? A plus BI. Okay? The value A is called the real part. And the value B, not BI, but just the B, just the number in front of I. The value B is called the imaginary part. Right, all right. So what we're going to do now is we're going to look at some properties of the complex number system, okay? What we want to do is we want to make sure that we simplify as much as possible, okay? So, for example, let's start with I, okay? I cannot be simplified. I is I, okay? However, if I were to raise I to the second power, we know that I squared is -1, okay? If I were to raise it to another power, so I cubed, well, we know I cubed can be broken down. I cubed is the same as saying I squared times I, Well, I squared is negative 1, and then I is just I, which negative 1 times I is negative I. So I cubed is the same as saying negative I. So anytime you see I cubed, that's not simplified. That's like leaving a fraction 50 over 100. We don't leave a fraction as 50 over 100. We say 50 over 100 is 1/2. The same thing with complex numbers. We're not going to leave something as I cubed. We're going to say I cubed is negative I. Okay, so it can keep going. Let's keep going. We're going to do I to the 4th power. Well, I to the 4th power is the same as saying I squared times I squared. I squared is negative 1, so negative 1 times negative 1, which is just 1. Okay, now let's do I to the 5th power. I to the 5th power, let's see, we can break that up so many different ways. Let's do I to the 4th and I, right? You could have done I to the 3rd and I to the 2nd. Whatever, you will all get the same answers as long as your exponents add up to 5. So I to the 4th times I to the 4th is 1 times I. So I to the 5th is just I. Great. Now let's do I to the 6th. Okay, I to the 6th is the same as saying I to the 5th times I. Well, I to the 5th is I times I, which is I squared. And we know that I squared is negative 1. Okay, let's do I to the 7th. So I to the 7th, let's go ahead and do I to the 5th and I to the 2nd. Again, you can choose anything you want as long as it adds up to 7. So I to the 5th is I to the 2nd. I to the 5th is I. And I to the 2nd is negative 1. So I times negative 1 becomes negative I. All right, let's do I to the 8th. So I to the 8th, we can do I to the 4th times I to the 4th. Okay, and I to the 4th is 1, so 1 times 1, which is 1. Okay, so we can keep going. We can keep going and keep going and keep going. But I don't know if you noticed this, but there is a pattern here. It goes I, negative 1, negative I, 1. I, negative 1, negative I, 1. That pattern is going to repeat itself for the rest of its life. Okay, you can keep going with this pattern forever and ever and ever. Okay, you don't have to do any more work as long as you know I, negative 1, negative I, 1. I, negative 1, negative I, 1. And you just repeat it over and over and over. Okay, however, if you have a big number like I to the 63rd power, I don't know about you, but I don't want to have to write this pattern 63 times until I figure out my answer. Okay, there's actually an easier way. The way is that, notice that this is every 4 times it starts over, right? Every 4 times it starts over. In fact, I to the 4th is 1. So if we can figure out how many i's to the 4th we have in an exponent, then we can cancel it out because it's just 1. Okay, so the key to this is divide your exponent by 4. Okay, let's look at an example of that. We're going to do I to the 63rd power. Okay, 63rd power. Well, again, we're going to take our exponent and we're going to divide by 4. So 4 goes into 63. 4 goes into 6 once. Bring down the 3. 4 goes into 23 5 times. That's 20. And you get a remainder of 3. Okay? So, guys, this is the part where if you were to plug this into your calculator, you would get 15 point something, 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 something. It would not be 15.3, I'll tell you that. But it's going to be 15 point something, 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 something. That's not going to help you. You have to do long division, and you have to figure out what is the remainder. Okay? And this is why. Because now I know that there are 15 groups of I to the 4ths. Okay? So I to the 4th there's 15 groups of them. Okay, there's 15 groups of I to the 4th. All right, which means that I have 3 i's left over. So I've got I to the 3rd left over. Okay, well, I know that I to the 4th is 1. So now I've got 1 to the 15th power times I to the 3rd power. Okay, well, I know that 1 to the 15th power is still 1. So now I've got 1 times I to the 3rd power. And 1 times anything is itself, so now I've got I to the 3rd power. And then I know that I to the 3rd power is negative I. So I'm done. Let's talk about more properties of complex numbers. There are some formulas that you can memorize when you add, subtract, multiply, and divide. I will go ahead and put the formulas. So there's 2 ways when you're adding, subtracting, multiplying, and dividing. The first way is to just do it. Just add, subtract, multiply, and divide, and, do the FOIL method and rationalize your denominator, multiply by the conjugate, knowing how to do all of that. If that's something that you think you're going to struggle with, you can also memorize the rules, right? So I'm going to go over the rules for you, the operation rules for complex numbers. So let's say the operation is addition. You're going to add 2 complex numbers together, okay? Well, the rule will say this. A plus BI, that's one complex number, plus C plus DI. This is the problem. That's the problem that you have. You have to add those 2 complex numbers together. Now, this is the formula that you're going to use. You're going to use the formula A plus C plus B plus D in parentheses I. That's your formula for addition. Now let's look at the formula or the rule for subtraction. So that's going to be something like this. A plus BI minus C plus DI. That's the problem you're up against. You're going to use the rule A minus C plus B minus D I. There's the rule for that one. All right, now the rule for multiplication. So this is one where you have a rule, right? We have this rule that we're about to and it looks like a formula. But you could also do the FOIL method or the box method and use your properties of complex numbers to get the answer, the same exact answer. So again, if you don't think you can memorize the rules, that's fine. You can still do it by just using properties of complex numbers. So multiplication is going to be a problem like this. A plus BI times C plus DI. And you can use this formula or this rule. AC minus BD plus AD plus BC I. All right, last operation is division. Okay, so this is going to look like something like this. A plus BI over C plus DI. So this is where you would use your conjugate, C minus DI, and you would multiply numerator and denominator by C minus DI, and you would get your answer and rationalize it. That's one way to do it, okay? Or there's also a rule that you can use, and the rule says this. AC plus BD plus BC minus ADI all over C squared plus D squared. That is your formula rule for division. All right, so now we're going to do some examples, and I want to do these examples both ways. I want to do with the rule, and then I want to actually do it just by using properties. So we're going to do both. So that way you can see which one you like better and which one you're going to use, okay? So we're going to let Z1 be 2 plus 4i. Z2 is going to be 5 minus 7i. Okay, and the first thing we want to do is we want to do Z1 plus Z2. Okay, well, since that's addition, it's going to be 2 plus 4i plus 5 minus 7i. So this is the addition, right? That's the operation, addition. Okay, so again, I'm going to do it both ways. I'm going to do using properties and then using the rule. Okay, using properties, I'm going to go ahead and drop the parentheses. So now I got 2 plus 4i plus 5 minus 7i. Then I'm going to combine like terms. So I've got 2 and 5, which is 7. So I've got 7 plus 4i minus 7i. Okay. Now I can factor out an I. So now I've got 7 plus I times 4 minus 7. 4 minus 7 is negative 3. So I've got negative 3i, which is the same as saying 7 minus 3i. Okay. You could have just said, well, Miss Moss, that's just combining like terms. 4i minus 7i is negative 3i. Yeah, I know. Same thing. Combining like terms. But remember, combining like terms is doing that. It's factoring out the common part of the term and then adding or subtracting the other piece. So again, yes, 4i minus 7i, you don't have to do all of that. You could just say, well, 4i minus 7i is negative 3i. That's fine too. Okay? So now let's do the rule. The rule says that a plus bi plus c plus di is equal to a plus c plus b plus d I. Okay, so first I have to figure out what is a, b, c, and d, right? Well, since it's z1 plus z2, that means that this is a, this is b, this is c, and this is d. Okay, so a plus c, so 2 plus 5, plus b plus d, so 4 and negative 7. So 4 plus negative 7, I. Well, 2 plus 5 is 7, plus 4 plus negative 7 is negative 3. And then negative 3i is just minus 3, so 7 minus 3i. Same answer. There you go. All right, we're still dealing with Z1 and Z2, but now we're going to do another operation. We're going to do, let's do subtraction, okay? So we're going to do Z1 minus Z2, okay? So Z1 was 2 plus 4i, so 2 plus 4i minus Z2 was 5 minus 7i. So 5 minus 7i. Okay? So properties versus your rule. So properties, the first thing I want to do is I want to drop the parentheses. But in order to drop this parentheses, I have to distribute the negative. So I'm going to distribute this negative to the 5 and to the minus 7i. So now I've got 2 plus 4i minus 5 plus, because negative and negative is plus, 7i. Okay, combine like terms. 2 minus 5, negative 3. 4i plus 7i plus 11i. All right, now for the rule. The rule says that if you have a plus bi minus c plus di, you're going to do a minus c plus b minus di. Okay, so first things first, what's a, what's b, what's c, plus what's d, right? So again, you go up here, a, b, c, d. So a is 2 minus c is 5 plus b is 4 minus d is negative 7. Okay, so 2 minus 5, negative 3, plus 4 minus negative 7, that's 11i. Oh, look at this, same answer. Like I said, it doesn't matter which method you use, you're going to get the same answer. It's what you feel comfortable with. All right, next operation is multiplication. Okay, so we're going to do z1 times z2, which is saying 2 plus 4i times 5 minus 7i. So we can do this operation using our properties or by using our rule. When you use your properties, you're going to FOIL. Okay, I do the box method. Actually, I'll do both, box, FOIL. Okay, so box method, we've got 2 and 4i. We've got 5 and negative 7i. Okay, so 5 times 2 is 10. 5 times 4i is 20i. 2 times negative 7i is negative 14i. And then negative 7i times 4i is negative 28i squared, right? Because I times I is I squared. So now I've got 10 plus 20i minus, what was this, 14i minus 28i squared. Okay, so there's a couple of things we need to do. First, we need to combine like terms. So this is going to become 10 plus 6i. Okay, and then the second thing we want to do is this I squared needs to be simplified. So now we've got minus 28, but I squared is really negative 1. So now I've got 10 plus 6i, and then negative 28 times negative 1 is positive 28. Combine like terms again, 10 and 28 is 38. So 38 plus 6i. That's the box method. FOIL method, let's go. 2 plus 4i, 5 minus 7i. All right, so first terms, 5 times 2 is 10. Outer terms, 2 and negative 7i, which is 2 times negative 7i is negative 14i. Okay, inner terms, 4i and 5, which is 20i. Okay, last terms, 4i and negative 7i, which is negative 28i squared. Okay, awesome. Combine like terms right here, this negative 14i and that 20i. Those will be combined. So now I'll have 10 plus 6i. This I squared is going to become negative 1, so negative 28 times negative 1. So 10 plus 6i plus 28. Combine like terms again, you get 38 plus 6i. So again, same answer. All right, let's do the operation rule that exists, right? The operation rule says that if you have a plus bi times c plus di, you are going to do this. You're going to do ac minus bd, plus AD plus BC times I. Okay, so again, A, B, C, D, we have to know what those are, right? We have to know what those are. So here's A, B, C, D. Okay, so AC would be 2 times 5, right? So 2 times 5 minus BD, so 4 times negative 7. Okay, so that's this piece, plus AD, so A times D, so 2 times negative 7, plus BC, so 4 times 5, I. Okay, so 2 times 5 is 10, minus 4 times 7 is 28, so that becomes positive 28, so plus 28, plus 2 times 7 is negative 14, plus 20, I. So 10 plus 28 is 38, and then negative 14 plus 20 is 6. Oh, there we go. Same answer. Awesome. All right. Last operation that we want to do is we want to do division. Okay? We want to do z1 divided by z2. So this is our last operation, z1 divided by z2, which looks like this. It looks like 2 plus 4i all over 5 minus 7i. So properties versus rule. Okay, so for our properties, what we would have to do is we would have to multiply by our conjugate, which would be 5 plus 7i. Okay, so you would have to either FOIL or box method the top, FOIL or box method the bottom, right? So I'm going to do box method because that's the method I like, but again, you can use the FOIL method, right? So 2 plus 4i times 5 plus 7i. Okay, so we get 10, 20i, 14i. Oh, this is, yeah, it's positive, 14i. And this is 28i squared. Okay. So 10 plus 20i plus 14i plus 28i squared. Combine some like terms, and that becomes 34i, and that's going to become negative 28. So 10 minus 28 is negative 18, so negative 18 plus 34i. Okay, and that's just this piece, the numerator. So negative 18 plus 34i. What about the denominator? We have 5 minus 7i times 5 plus 7i, right? So again, we can use our box method. So 5 minus 7i, 5 plus 7i. So 25. This is negative 35i. This is positive 35i. And this will become negative 49i squared. Okay, so 25 minus 35i plus 35i minus 49i squared. The 35i's cancel each other out, leaving you 25 minus 49, and then I squared is negative 1. So 25 plus 49, which is 74. There we go. That would be that part, okay? That's not done though, however, because then you have to simplify that, okay? The first thing you would want to do is you want to factor out anything you can factor out here. So 18 and 34, the least common, or the greatest common factor is 2. So 2, and then you're left with negative 9 plus 17i all over 74. Now the 2 and 74 will reduce, leaving you negative 9 plus 17i all over 37. And last but not least, you want to split this up into real and imaginary. So you have negative 9 over 37 plus 17 over 37i. Final answer. That was a lot of work using properties. Let's see if using the rule makes it any easier, okay? So the rule says if you have a plus bi over c plus di, you can use this rule. AC plus BD plus BC minus AD I all over C squared plus D squared. First things first, what's A, what's B plus C, all that, okay? So here we go. Here's A, B, C, and D. I need to change colors though. All right, so A times C. So 2 times 5, right? 2 times 5. Plus B times D. So B is 4. So 4 times, and then D is negative 7. All right, so there's that piece. Plus BC. So what was B? B was 4 times C, which is 5, minus AD. So 2 times negative 7i, right? That was the numerator. All over c squared, so 5 squared, plus d squared, so negative 7 squared. All right, so 2 times 5 is 10. 4 times negative 7 is negative 28. Plus 4 times 5 is 20 minus negative 14i all over 25 plus 49. Okay, so 10 minus 28 is negative 18 plus 20 minus negative 14 is going to come 34i all over, this is 74. Okay, if you notice, this right here is the same thing that we had up here. Okay, so once I've done this, now the last step would be to do this piece right here, and we would get the same answer. Okay, all right, that's all I have to show you. That was the last operation, and that's actually the last thing to this section. So the section is done. So you're going to try 2 through 6 on 7.1.